This episode is sponsored by Krim. Krim skillfully designs and manufactures professional coffee equipment like their Onyx manual espresso machines, Coffee Queen filter brewers, and Unity, their fully automatic coffee makers. These sleek, versatile, and reliable machines come with proactive service plans to ensure a differentiated and seamless coffee experience for coffee professionals and enthusiasts. Find out more at krim.coffee. You're listening to the Coffee Podcast. This is the Coffee Science series. What is coffee science? Before we do an entire series on coffee science, at the moment at least 12 episodes worth, I felt it was good and necessary to have a relaxed, sit-down conversation with a member of the coffee scientific community to define some terms and warm up to the conversation at large. Jeremy Nelson is a scientist, a researcher by training, specifically a neurophysiologist, and has a love of coffee that has stretched over the last 20 years. What started as a fascination with home roasting soon moved him to help judge U.S. Barista Championships, where he discovered the coffee industry needed something more than say-so science. It was around that time he met Joe out of Sydney, Australia, and they struck a phenomenal collaboration effort, today known as Socratic Coffee. For context's sake, Jeremy develops the experiments and Joe performs them. We learned that years ago when Jeremy joined us for the first time on episode 72 in 2017 to talk about the gap in coffee research. Jeremy was kind to sit down at the microphone with me and riddle around with the questions. What is coffee science? And what are some ways we can think about science in coffee? These days, him and Joe are playing with some cool science gadgets to get a closer look at particle distribution.
Recently, we got like a new piece of machinery that we're really excited about in the lab. So we got a digital imaging particle analyzer, which is, a fantastic piece of equipment that lets us do more thorough particle distribution analyses. And, I can go into the kind of nuances and details about that, but that's something that we've been working on for months, because we work really hard to make sure that our protocols are sound, that we understand the data that we're putting out. And so This is like a really complex piece of machinery. So we haven't released a lot because we still ourselves are trying to understand, well, is that meaningful? Because one thing that we could do is put out data for data's sake, but people might take it and make all sorts, they might over extrapolate and make inferences that just don't exist. We try to minimize that. And so if we put it out there, we stand behind it. That's something that I feel like Socratic is pretty good about.
There's an obvious carefulness with which Socratic comes to the scientific conversation or the conversation regarding results from experiments. I'm curious, over those years of doing experiments and looking at the data, what would you consider to be the key challenges in performing good experiments in this environment?
That's a good question because, obviously a main challenge is resources, right? And resources being consumables for the experiment itself, as well as just our time, particularly Joe's time, because we're geographically not in the same place. I could make a tremendously laborious, awful experimental design and then have no appreciation for how much work that takes Joe. I will, through WhatsApp and Instagram, communicate with him and see, wow, that's a 12-hour experiment you've been working on. I had no idea when I made that. I knew it needed to have all of these, it needed to have all these samples. So I think that has been interesting. And then Joe, he worked so diligently at doing the experiments and being very controlled and making sure everything is perfect. And then has to put all the data into spreadsheets that I can then analyze. And over the 6 years, we have families and they've grown. And so, that like really eats into extracurricular time. So that has kind of slowed us down a bit too, especially me. I'm going to say it's mostly my fault. So it's not uncommon for us to collect a bunch of data, and then Jeremy is not as punctual at getting the analyses together. And another thing is, early on I had this idea that we would kind of write it in like a scientific journal format. And so we, if you go to our website, people often go to the website and notice it hasn't been updated for years, because we tried to, that was the initial idea. And then we were like, Instagram seems to be a great way to connect with people, but it's not a good way to catalog stuff.
Yeah.
And so we've kind of gone round and round over the years. We still don't have a great model for how to, easily let somebody go back to old experiments and data. So, maybe we'll find a solution to that. It's tricky because we don't have, it's a hobby for us. One of the things that is a key, actually a big challenge, if you were like an academic lab, they have these really high grade pieces of equipment. Some of the like Italian labs that you'll see studies in like espresso, they essentially just make their own espresso machine so that they can control variables that like we just can't in the equipment that we use. Science is constantly a balance between what's called external validity and internal validity. And so external validity means like it's kind of in a contextual environment that the data was collected in, the results are applicable. But internal validity, you kind of strip that and you try to really understand like a basic principle about something. So if we just wanted to understand something very pure about coffee extraction, right, we would remove all these variables to just really hone in on that.
Okay.
So that would be internally very valid. But when you extrapolate that to a cafe environment, for instance, maybe it doesn't apply as well or something. So we are kind of on that end closer towards clearly the externally valid stuff, right?
Yeah.
So we'll test like a new toy for espresso preparation and see and try to assess the impact of that, which is externally valid in this sense. But people often want to say, well, how did it, how well does it actually, I'm going to like pick on, like a distributor device. How well did it actually incorporate? And we're, that's moving the needle more towards that internal validity of the basic, do the particles need to be swirled up in some sense? So we're just trying to say, is the tool effective or not? Externally very valid. Internally, the question is more like, well, what's the mechanism driving any change if observed? So I like to say we're consumer reports, right? Because like consumer reports is not doing any sort of foundational physics type testing, but they are letting you know if that's a good car versus that car.
Yeah, no, I see what you're saying. And I think that even based on what you're saying here, what Socratic offers is something you can immediately apply to, say, like, if I own a cafe, I can say, do I really need XYZ tool, or do I need to pay this much more money for this thing that the industry culturally says is like you got to have, or am I okay without it? And there's a lot of stuff like that in coffee where something's said and the industry is just like, yeah. And then we all jump on the train, and then while the train's moving are like, wait a second. Or maybe we don't even realize it yet because nobody's come around to saying, hey, this just doesn't add up. So I've been guilty of that, and I think we all have been. And so it's nice to have somebody or an organization doing something where you can say, oh, here's like, I guess just evidence for me to make a decision A or B. So
yeah, if you look at the questions we have tackled in the past, or just attempted to explore, I don't want to say we've been successful in tackling any one thing. It's always Joe and I will say like, hey, what grinder should I get in my house? Like it could be as simple as that. Yeah. And then, it'll lead down this path of like, well, how do you know what's a good grinder? How do you compare, right? And there's just not a lot of objective data out there. So in one of my past jobs, I did a lot with human performance, and so I had to do objective measures and then had to do a lot of subjective measures. And I don't trust people who like do 10 taste samples of a thing and can tell me that this is significantly different. I know too much about the sensory system and just about subjectivity and subjective ratings in general, where that's not going to sway me. I would just rather, say, oh, I see this particle distribution versus this one, and I know that I seem to have a preference for this particle distribution, so that's the grinder for me, right? If we want to kind of extrapolate that. So
as far as objective versus subjective, can you give us like just some concrete examples of the difference between those two observations you might make in an experiment?
For sure. If we pull shots, this is why I think last time we talked, you had asked like what has been a thing that really changed the coffee scene and or made Socratic possible, and I said it was the refractometer that had coffee dissolved solid content correlation. I mean that is the objective tool that we all needed, and to get it to a point where the average consumer could do it his or herself is great. So we've got this tool that it doesn't matter what you or I think, like it's just going to spit out a number and it's going to say the dissolved solid content of the solution that you have made is X. And you and I can taste it and you can say it tastes more astringent to me, and I can say, oh, it tastes more, I don't know, acidic, right? And I don't know what to do with that information, right? I don't know what you ate prior. I don't know if you have a stuffy nose. There's so many things about that subjective thing and there's sensory fatigue, so basically subjective is it's not measurable through some sort of an instrument, right? So if I'm just rating on a scale what I perceive as intensity, there are ways that you can do psychophysics where we could try to get closer to an objective scale assessment, but to do that you have to run insane numbers of you would have to taste so many samples, and you have to do it in such a random order. And we could reference the UC Davis paper that just came out with the with temperature not affecting flavor is kind of what they were claiming in a very simple sense. So that's a cool example of internal validity, right? So they are going to examine the impact of a variable on flavor perception, right? So they took a subjective measure, flavor perception, and I when I looked through the paper, I'd want to know more about this trained panel and all of the metrics, because sensory fatigue, especially in gustatory and olfactory, is pretty strong. You have to. So I don't know. I know they did like 200 something. They did a lot of samples. There's a lot of scoring in there, which there has to be. But what orders did they do it in? Because you got to randomize it. Yeah. And the other thing that to go back to a question where you said what is a challenge, sometimes we want like the same batch of coffee to do an experiment, right? You don't want roast variable to be a chain, or you don't want roast to be a variable that you have to worry about, right? And so sometimes we do experiments where we need so much coffee, and it's the biggest batch you can get, and outside of that, like, do you get like a couple days later, get them to roast it hopefully as close as possible? Like we try to never do that. We try to do it all in one roasted batch, because that's just a variable that we don't. And so I'm looking at this UC Davis one thinking like, you can have an amazing roast, right? There are people out there who are incredible at tracking their variables and probably get very close to nailing it the same way every time. But man, if you're going to do like what I think I saw, they were like 200 something samples. Right, how many different roasts of coffee was that? And, like that's I would love to. Yeah, I wish we could I wonder if we could take their data, if they would give us the raw data, and if we could just plot it against, see if there's any correlational thing with roast. I don't know, who knows?
We have the scientists who worked on that exact experiment on the show, and they kind of talk a little bit about that. So it'd be cool to tie what you're asking to those experiments. And I think even more, maybe there'd be an opportunity to have like a panel discussion down the road.
Okay, I'd love to see, because a study I did once, I used extremely well trained. I used fighter pilots, right? Like, in a pilot-oriented task, and I can still show you how subjectivity fails in that group, right? I did what would be called like a linear paired comparison approach to try to add like an anchor, almost like an objective measure in subjectivity. I don't know enough about the details of how they did that, but it gets, I'm just saying it gets so complicated and it's really hard. And that's why just we are, as two dudes, we just do not mess with that. Like I would never want to put something out there where Socratic Coffee tested 2 different brewers and they found that this one totally makes a chocolatier tasting coffee or something, right?
You want to talk about extraction, something you can measure versus flavor. Flavors I think can be scary to try and put a label on. And I know in some ways the industry, some people in the sort of subculture and specialty are really pushing against being so specific about flavors. There's sort of this response to being very specific. So we have like the lexicon, right? Or the flavor wheel.
So we should talk about that, because since we last talked, that to me has been the best thing the coffee community has done was, that World Coffee Research sensory lexicon, where you have an actual sensory anchor with intensity given a preparation. I mean, that.
When you say anchor, what do you mean? Because I've heard you say it a few times now.
So an anchor. Yeah. So an anchor, to me, I'm using that word to say, if I tell you blueberry at medium intensity, 5 out of 10, we both need to experience the same thing. We need to anchor that to a thing.
You quantify it somehow. Is the idea?
Yeah. So in the sensory lexicon, they have like Smuckers prepared at. No, they do. They really do.
I know. I've seen it. Yeah.
Yeah. So you mix it. You put it in a cup. You cover it. Like, then we both experience that, and now that's our anchor. We know that is a 5 of this flavor.
Right. It's common. It's like common ground to be like, we both tasted Smuckers, yada yada, and when we taste this cup, if we're both tasting Smuckers, then there's like this. Yeah. That makes total. So that's our anchor. That's the idea of an anchor.
Yeah. Okay. So if I say like this, I get blueberry, I get medium intensity blueberry in this coffee, you and I both know that we're trying to say it reminds me of that Smucker sample that we had. So we do in the barista championship stuff, I haven't done it for years, but when we used to judge sensory judging, I mean, what we called it was calibration, right? So you had like the head judge would come around, a shot would get pulled, and then we'd all sample it, and then all just kind of like toss out our scores, right? And then and then you were kind of told to readjust to be in line with everybody. I can't speak too much about the barista championships. I don't know how they're done, but it's like head judge doesn't really judge you, but head judge really influences everybody else's score. Okay, so
that makes sense.
Take that as you want.
Yeah, they're like the guide. They're like the Yeah, I'm tasting this at a 3. They taste it at a 6, and so I should be at a 6, not a 3.
Exactly.
Okay. All right.
Which if to get to the beginning of Socratic Coffee, before I launched Socratic Coffee, I was noticing that. Like, I would go with a head judge. I would be told that's a 6, and I thought it was a 3. And so I said, okay, I'm adjusting myself to this being a 6. And then I get a different head judge, and I would be like, that's a 6. And they'd be like, no, that is a 2. And I was like, oh, okay, this is a 2 now. And so I did an analysis. I did a statistical analysis that showed who your head judge was something like, I forget. It was by far the most predictive factor on how successful you would be in a competition.
Oh, who your judge is.
Everything else away. Who your head judge.
Who your head judge.
The person who does not write a score on your paper, right? Like, you get no score from the head judge, but your head judge influences the whole tasting, the sensory panel.
Do you still have that data?
Yeah, well, no. I sent that in to folks, and they laughed at me like, oh, what'd you do? Run a Tukey test? I mean, I can't. I was so that was like the impetus that kind of got me like, I'm gonna do my own scientific thing.
Yeah.
Where I don't have to answer to anybody.
Yeah, you went greaser on them.
But I mean, I clearly demonstrated that the competitions were unfair.
Yeah.
And their response was to laugh at stats. And so
we'll say, like, in the category of non-traditional scientific organizations. So things like Socratic. Is that that's a fair category, right?
Yeah. I mean, you can use whatever words you want. The non-traditional meaning like we're not some sort of academic lab or industry lab. Yeah.
So in the world of non-traditional scientific experimentation in coffee, you mentioned there's this like spectrum, different kinds of organizations. Can you tell me a little bit about what you're thinking there? Let's tease that out.
So I guess we want to talk about on one end, you have people who are very knowledgeable about coffee and are able to have and maybe even a platform, but they're provocateurs. They can throw out these very interesting ideas, but they maybe don't have the skill sets, equipment, and or time to validate those, right? But they make very kind of persuasive and or provocative statements, right? Okay. So I'm gonna say that's like on one side, and then on the other side, right? And so that's those folks. They might make claims about things that are cafe oriented, so I'll say like kind of in that externally valid world, as well as they might make very basic principle internally valid kind of claims. So I don't know, but that's what they are. So you got these provocateurs, and then you go all the way to the other side of the scale, and you've got like a very clean and pure kind of academic lab who is going to like control to the best of anyone's ability every variable and really hone in on the effect of A on B or something to that effect, right? Yeah. So that's kind of your spectrum. You've got like this clean experimental setup group, and you've got these provocateurs, and you need all of that, right? Because provocateurs bring up the great questions, and they kind of push us to say like, oh, maybe that's not the way it should be, or whatever. And so Socratic is like, we try to be, I can't say we're right in the middle, but we try to be somewhere in the space of, we hear a claim or a thing and we say like, we can do a pretty good assessment on that. And that's the kind of the world that we live in. We don't have all that really fancy equipment, and we don't have all those resources, but we've got pretty good stuff, and we've got sound methodology, and we know how to do it. So that's our space, right? So we're kind of in between those two. So we've got, you've got your really the people who say and kind of move the coffee industry. So your Hoffmans and your Scott Rayos, and that's on this side, and then that's not knocking them at all, but they live in that space where they're always making us think about things. And then you've got your UC Davis group that is like probably your food science, chemical engineers who are going to be very rigorous. And then in the middle, you got Socratic coffee of two dudes with like a hobby lab.
Yeah, no, I think that's great. I think that paints a really good picture for the series, even from like an introductory sort of perspective of like I've had this challenge with the series so far, which is like, we're talking about coffee science, but like you almost have to define science because the series is touching on all kinds of different science. So even like the world of life sciences versus the world of physical sciences, right? So here's like just a quiz, or not a quiz. This is categorize the things that I give you, that I say here, because this will be helpful for me and probably for the listeners. So I'm going to say a science, and then you give me a category, either life or physical. Okay?
Okay.
I don't know if this is going to be good or not.
Yeah, this is an interesting experiment. Yeah, we could do it this way. We can also do it another way, but let's try it this way first.
Yeah,
let's see what happens.
Yeah, let's try it. So I'm going to say history.
History. So there's life and physical, but there's soft and hard science, right? So I'm going to put history in the soft science, right? Okay. Like a hard science, you can control a thing and have you can essentially have, let's imagine a very basic sense. You could have, history can't be a hard science. You can find what we'll call natural experiments, but you can't really do an experiment in history, right? You can't say these two things are the same. One's exposed to a variable and one is not. Let's look at the difference. So it's going to be a soft science.
Okay.
So we'll throw it in the life sciences if you want, but it's in the soft science space.
Okay, and then we'll say chemistry. So the idea of like what is in coffee or what makes coffee.
Yeah. So we could get real philosophical here, right?
That's fine. Yeah.
There are strands of chemistry that you could call like theoretical chemistry, right? Where you could say some of these definitions that I'm kind of throwing out are not going to fit. But in general, chemistry would be a hard science and it would be a physical science, because I can set up experiments and I'm measuring physical interactions in the world that don't have as much variability. And, I'm sure there's going to be somebody who could argue with that, but in general, I can take like a pure amount of an element, a pure amount of another element. It's not going to be like, oh, these hydrogen atoms were raised under these conditions. So they're, so I'm jumping to humans, for instance, right? If I take a bunch of humans and they've all had different life experiences and et cetera, there's a lot of variability in that. Mm-hmm. In like these kind of like hard physical sciences, you can get pretty pure samples to test of a thing for the most part. So that's kind of like one of these breaking points between like the life science and the physical sciences, and then the hard science and the soft sciences. Like, can you set up true experiments? And these are just my definitions. I'm sure that there are other ones.
This is totally the point. This is like for me too, to just be like, it's okay for me to feel uncomfortable approaching the word science, because it can be very philosophical and like without a technical experience or understanding of it from a long life of like working in science, I think it helps me to feel like it's more approachable, to know that it's not so approachable. Does that make sense?
So, I mean, we can talk about like, to me, science is simply an approach, right? Science is a method to arrive at good information about the world, right? And what that means is that sometimes we update the information because we found like, oh, we can do better, or there was a flaw in that. And so I am totally cool with like facts about a thing changing, because I know that it was collected in a good way and then it was collected in a better way in the future.
Yeah.
But some people say like science says this, and then if scientific studies come out that show something else, people are like, oh, science is terrible. They told us that eggs were good for us, and now they say eggs are bad for us, right? Like science is trash. You're like, well, it's not science that's bad. Science is simply the method, the process. And I think people who are scientists tend to like know that we just live in this like ever changing, fluctuating kind of world, right? Because we're always updating our information and hopefully improving and getting closer to, big T truth and whatever we're studying. So you should always look at science. You got to be skeptical, that's the nature of the beast. And that's what a good scientist is. A good scientist is skeptical. And, I know you want to probably at some point say like, well, what are some key takeaways from this? And I would hope to like, be skeptical of stuff, know how to hopefully get to the point where you feel confident in like questioning and really digging in, and always look at primary source data yourself the best you can. And then, you got to look at ulterior motives, because in the coffee world, when somebody makes a claim, but then they also happen to sell something, I always kind of, okay, right? Like maybe, but if you're not going to put your data out there and if you're just going to make the claim, but you're not going to let us see the data itself, or there is no data, why would I believe you?
Yeah.
You're trying to sell something.
Yeah.
So.
No, it's good.
You should just, here's the evidence, and here's the methodology, and we can all critique that and see if it's true or not. So.
Yeah. I want to talk a little bit about some of the specific challenges you've observed for coffee science. I know that we talked about like the shape of, say, a coffee particle would be maybe something that was important. Or we could talk about the challenges in presenting results. And you kind of mentioned that for Socratic, there's like resources of time, like putting together a good visualization is not easy. Like in some ways it's not hard to plot something. It's not hard to like put data into a plotting software and just like put it up there. But presenting the data in a way that's meaningful, or that really says what it should say, is not so easy. So we could talk about what do you perceive to be the challenges, say, in Socratic's perspective?
Well, I like want to talk about all those things, right? Because I think you always have to look at what are the assumptions that feed a thing, right? So if we're going to talk about the particle analysis, because we're just struggling to like figure out what makes sense to present to people. So everybody likes the laser diffraction approach, which uses light scattering and then it calculates how big the particles were, which is fine, but that is based on everything being a round, smooth sphere, which coffee particles are kind of like the antithesis of round. So I feel like that is a terrible assumption. And so I don't know how I trust. I don't really feel comfortable with a lot of the results when I see these particle distributions. But at some point, you got to figure out what approach you're going to use. They all have downsides. I would love it's like the MIE, right? It's the approach that is used for this light scattering computation. And what would be really cool, and I have pitched it to some folks who are much smarter at these things than I, to say like, well, can we look at deviations from spherical, and then we can just start seeing how that skews like our data. So if I said, okay, it's starting to look like a football, we're going to assume everything's a football now, and then like what does that do to the particle distribution, right?
I guess my question, because I've heard people say this before, they'll be like, well, it all averages out, right? This idea of like,
no, okay, whatever. Where did you come up with that? So what's cool about our approach, when we were looking around for an imaging machine, we picked a camera. And so our camera kind of almost does the opposite of this diffraction. And so what we do is particles fall through and we have a real fast camera that takes a picture. And so what we can do with that is now we know exactly what the thing looked like in a 2D-ish sense. And we can make it look like laser diffraction by putting a big circle over it, right? And we'll count it the same way your LPA would have done. So we can do all these other geometry measurements. And so we can make it correlate with because we have that sieving stack and that big protocol that we put all the particles, and we have a bunch of different size screens, and the particles kind of fall through. So we do that. We can correlate to that, or we can correlate to laser, and then we can do all these other things. So we can look at bluntness, like the oblong shape. But what we're struggling with is like, how is that meaningful? I don't know. Like if I tell you like, okay, that grinder makes super blunt particles relative to that one.
Yeah.
Is that useful? I don't know.
I guess I don't know. But if you were to say like sort out, you couldn't really sort out the different shapes of particles and then test them individually, because that would be interesting. Like you couldn't say that one looks like Charlie Brown's head and then, just sort all of the ones that look like that into a pile of 30 grams and brew it and measure extraction against something else.
Well, I mean, that's interesting. I don't know. I have to think about it. So, no, here's the thing where find a physical science person who does soil or something, right?
Oh, yeah.
And say like, how when you're trying to make a uniform sample of particles, like what do you do? Because there might be something out there that might be aspects about like a shaking table, and certain things kind of tend to agglomerate or kind of, who knows? This is why, again, I'm neurophysiology, right? Like I always go back to that, like, let's talk about blood flow in the brain or neural, communication or something like that. Cool. I feel much more comfortable when we start talking about, right? Like all these, I don't know. This is why we're fortunate, like, because I think some people early on in Socratic saw what we were doing, like real scientists who just really liked coffee reached out to us and have like become great advisors and mentors to us.
Cool.
So like really distinguished, really amazing people have, right? Like there's my academic life where I get to interact with people, but then in the coffee world, I get to interact with people who are like superstars in their specific fields of chemistry. And those folks are so nice to give me any of their time to like help me in my little hobby of, right, where I'm just probably asking like silly questions that they would be like my undergrads wouldn't even ask that question, but they're so nice. And so we've gotten a lot of help over the years, because we don't know. Like for a while we were going down this path where we thought like viscosity of coffee could be an interesting metric to be assessing. But I don't know. I didn't know much about like microfluidic arrays. We had to get people who are familiar with that, or there are physicists who specialize that we've talked with on like really things as you draw down and scale, they start to act like funny. And so small particles, when they're bouncing around and jostling, like they might not jostle the way you think that they would. And
Yeah.
just there's a lot to know, and no one knows it all. So it's cool that coffee can, like, we can reach out and sometimes find people who are like really willing to engage us. So
that's cool. Yeah, I like the idea of collaborating across boundaries, like typical boundaries, for the sake of just understanding something, especially in coffee. So
yeah, I wish if we presented that spectrum right again, like I wish you have, and I don't want to say provocateur is a negative thing, right?
Yeah.
It's simply somebody who puts out an idea that is intriguing, maybe goes against kind of the norm or whatever.
Mm-hmm.
And so person A does that, Socratic kind of fits next, we kind of test the best we can, we think we get some good data, and then, like, you get over here to like a UC Davis lab where they like break down what Socratic did and do an even more rigorous but very focused thing, right? And so if you had that whole spectrum covered, it would be super cool, right? Like maybe that would be a way you really push like an aspect of coffee.
Yeah, it would be cool to see more of that. It's a little weird for me because in the series, I do have experts across different fields that are all coming together so that I can make a series about coffee science. But like if we all actually did something a little more coordinated, I feel like the impact could be massive.
Well, so when you're saying coffee science, in my head, it's understanding the process of extraction, right? Extraction being pour over, espresso, whatever, using a scientific approach. Right, like that. Mm-hmm. That's what I think of, and so there are certain people and approaches and things that I feel like are truly kind of fit on that, and then they're just the people who kind of like give us the questions. So yeah, I'd love to see how you bring this whole series together.
We're not just doing brewing science. I mean, we're talking about coffee agricultural science, and so like all the pieces coming together.
Yeah.
Well, almost all. It's hard to get them all because there's so many different kinds of like blankety science categories that I'm like, you brought up data science, which I think is a controversial one, and I think it's funny, but it's like, there's other things too where it's like fill in the blank science, and I'm like, do I include that or not include that on the coffee science series?
Right, right. Yeah, that's a like monumental task to include all the various fields of science that touch, all these aspects of coffee, from agriculture to like preparation. So that's, we've just bitten off like our tiny little piece, but you could just do a whole thing on just like the fermentation processes, that to me is just a fascinating, we don't touch that. And like again, as hobby, that's something you need to be like more rigorous in, I think your setup and skill sets. But the preparation part, we can dabble as like, we're not the chemical engineer food science, but we know a little bit, we can fake it.
I like how you talked about refractometer, because people who get really intense about their coffee at home could buy a refractometer if they wanted to. But I wanted to ask you, what might be a fun coffee experiment at home that you would recommend? Something that like with like super basic tools.
Yeah, that doesn't require a refractometer.
Yeah, maybe not. What's like the cheapest refractometer you think would be worthy of data points?
So the important thing is that you just, whatever you pick, you do it the same way. So you can get like a basic bricks, you can do an optical or whatever, those are pretty cheap. And just make sure you're not necessarily calling it TDS, because it's measuring bricks and there's a correlation factor there. But there is like a rule of thumb. I think it's like 0.85. You could multiply the bricks reading and get a ballpark. But if your point is just to have an objective, I'm going to say anchor again, right? Just get yourself a cheap refractometer and just say like, okay, I tasted that. Here's my anchor on what it scored. And then you can just do that. The things you want to control are like temperature and stuff. It gets tricky. These are all the headaches that we deal with in the Socratic world. But something that, honestly, a really cool experiment, you just need a fairly sensitive scale. You don't need a refractometer, is to go get instant coffee, because instant coffee ideally is like, it is all dissolvable solids. And so you can measure weight of water and weight of the solids and combine them, and you can get really, as I've done it at home, like you get really precise on what your TDS will be, because you can predict it. Because all it is like massive solid, dissolvable solids and massive water.
Yeah.
And so you get that, and then you can do fun things like you can say, okay, I'm going to shoot for a 1.5 TDS in this solution, and then you can calculate how much water to add to cut it, And it's just interesting to see, they call it in psychophysics, they call it JND, the just noticeable difference. Like, what is the change in TDS that you need to notice? If I give you a 1.5% brew and then I give you a 1.47% brew, that's, there was a 3-point change there. Can you perceive that change? And you ideally want to do more than just one sample of each, but what is the JND for people when it comes to filter pour over coffee? Is 1.49 and 1.47 really, like, can you really taste that difference? I don't know.
Yeah.
Espresso has bigger jumps, but to me, that's a thing I've played around with. But man, if I had a bunch of time on my hands, I would probably just go do a bunch of that. Like, and then kind of hone in on it. Looks like, a 5-point jump is what really is my big thing. So if I get a 1.5 and a 1.45, I can notice that. But anything in the middle, not that big of a deal.
Cool.
And then you start when somebody's like, here's a device that gives you like this increase, you're like, is that a noticeable difference? Right? You can start to question.
Yeah.
Just a thought.
No, that's cool. It's a cool idea. What are you working on, and how can our listeners be a part of that?
If somebody is interested in helping us figure out a way to better catalog and present and like maybe even write up some of our stuff, because I think we have a huge repository of information, so it would be nice to figure out a way to like comb through our old Instagram posts and stuff and like put it on maybe something like a website where everybody could go. And I'm open to hearing anybody who might want to assist with that. I think that would be kind of neat. Like I said, there's somebody who's a data scientist who we are kind of working with right now on one of our recent data collections to see if he can help us maybe present it in a better way that is a little bit more engaging and maybe more intuitive to folks. The other thing is just, be skeptical. And if there are like some crazy claims going around about something, like, let us know. Maybe we could tackle it. That's what we actually like doing, that being the Mythbusters.
Yeah.
That's fun.
Yeah. We have a lot of really interesting coffee science episodes ahead of us, so be sure to hit that subscribe button on whatever podcast platform you find yourself listening on. I want to give a special thanks to Drew Millay, who did the intro music to the series. It'll be the series theme song, if you will. I want to give a special thanks to Todd Purse, who did the episode art for the series. Check it out on our Instagram. Just search The Coffee Podcast. And hold tight, because we have a lot of topics coming around. The first one we'll tackle is going to be about research in general. How do we understand it, and what should we think about scientific research? Following that, we'll talk about agricultural science. Then sensory science and health science, but I may swap that order, so hold tight on that one. Thanks for tuning in, and as always, and until next time, happy brewing.